Good afternoon. My name is Dennis Vantervelde and I'm the Director of Gas Up Energy Networks Australia. Welcome to the public comment webinar on standard ASNZS4645 gas distribution networks. This standard has been extensively reviewed over the last 2 years and is currently open for public comment. There are 3 parts to the standard. Today we'll provide information about the changes to Part 2. On Friday, we'll provide information on Part 3. Part 1 was covered on Monday and was recorded, so you can watch it later if you missed it. We will email the details of the channel of where we place the webinars. Your presenter today is Anthony Bonacci, the new Estate and Gas Service Contract Delivery Manager at AusNet Services in Victoria. Anthony is a member of the AG008 committee, currently reviewing the AS4645 standard. He holds an honours degree in mechanical engineering from the Royal Melbourne Institute of Technology and is a chartered professional engineer with Engineers Australia. He has 8 years experience within the gas distribution industry and has held roles in asset management, engineering and contract management. In his current position, he is responsible for the delivery of approximately 150 kilometres of new main lane work per year to service the growth areas of Western Victoria, along with the delivery of operational and maintenance programs that support the overall network. I will now hand over to Anthony, who will take you through the proposed changes to Part 2 of the standard. Anthony, over to you.
Thanks, Dennis. Thank you to the ENA for facilitating these webinars and to help promote the development of the standard. Welcome everyone and thank you for joining us. Today's session is the second of 3 webinars and we'll run over the proposed changes to Part 2 of the ASNZS4645 Gas Distribution Network Standard covering steel pipe systems. The standard part is the first of 2 provided as a means of conformance in support of the main standard document, Part 1, which provides performance-based approach to the safe, reliable and affordable management of gas distribution networks. The third and final webinar will be held on Friday and cover the proposed changes to Part 3, which provides the means of conformance for plastic pipe systems. Firstly, a little about today's webinar. I'll start off by running through some of the administrative points in regards to the standard, its development and the public commenting process. Reiterate the scope of ASNZS4645 and that of Part 2 covering steel systems. Run through the background to the revision and the principles which were applied to it. These sections have also been detailed in Part 1 webinar, so I'll endeavour to run through them pretty quickly. I'll outline the issues identified with Part 2 and how they were collated, and then run through the proposed changes to the standard section by section, focusing on some key areas of larger change. Also, I have sitting with me one of the subcommittee members that developed the Part 2 revision, Mark Annette, and the chair of the subcommittee, Mark Dragar, is also on the line. So please feel free to type in any questions as we go that you have on the standard at any time throughout the presentation, and we'll endeavour to answer them either immediately or at the end towards the end of the presentation, as we'll have plenty of time. So, the stages and outcomes for the development of the standard. Revision was proposed early 2014 and driven by Energy Safe Western Australia and ACO Gas, specifically to review and roll in learnings from incidences, one specific incident, and other learnings since 2008. Project setup, including forming of the committee, began in the lead up to the first meeting in April 2015 by Standards Australia. And the drafting process then continued over the following year or 2, along with a sequence of committee meetings leading to a final draft for Standards Australia editorial review. That final draft was then open for public comment in late February of this year, for public comment which lasts 9 weeks and closes on the 26th of April this year. The public comments received from that Standards Australia interface will then be reviewed by the committee during redrafting of the standard and resubmitted to Standards Australia for editing. A 2-week ballot period will then be held to confirm the committee's acceptance of the completed draft before it's issued to Standards Australia for styling and publishing, and that's expected in Q3 of this year. So to reiterate, all three parts of the standard are currently out for public comment, and that closes on the 26th of this month. The draft standards are also available via the Standards Australia website, along with a commenting template and instructions on how to submit comments back through Standards Australia to the review committee. The draft standards are also free, not requiring an SAA Global subscription. So I'd encourage everyone to take the time to review the standard and provide commentary. As they say, the devil can be in the detail. So the application of the standard and the scope itself. The standard specifies the requirements for the safe, reliable and affordable management of gas distribution networks operating to 1050 kPa that reticulate gas to consumers. Part 2 specifically is a means of conformance for steel networks. The requirements apply to the life cycle of new gas distribution networks or new assets introduced where existing gas distribution networks are modified or augmented. The sections on operations, maintenance, repair, decommissioning, gas quality and risk assessment may be suitable for the application to existing assets in existing gas distribution networks. The scope is also fairly well known and hasn't changed, so it applies from the outlet of any city gate or inlet to a distribution network to the outlet points at the end of consumer meters. The exclusions also remain largely unchanged, with the most specific for steel being that it does not apply to steel pipe that has a hoop stress of more than 20% of the specified minimum yield stress. The standards development has been keeping in mind the range of stakeholders that the standard has. That covers owners and operators of gas distribution networks, technical regulators and authorities that regulate those businesses, designers, engineering houses, consultants and the like, who are responsible for the engineering design of elements of the gas distribution network, contractors, including individual plumbers, through to larger organisations who construct and maintain elements of the gas distribution systems, equipment and material suppliers. Reflecting this list of stakeholders was a range of organisations that contributed to the committee that was reviewing the standards. So a little background on the revision itself. The ASNZS, sorry, one slide too far there. The ASNZS4645 Suite of Standards delivers the foundations for the design, construction, maintenance and operations of natural gas and LPG distribution networks. The key objective of this suite of standards is to ensure safe and reliable and affordable operation of gas distribution networks that reticulate gas from city gates or their equivalent to consumers. These standards adopt a performance-based approach for gas distribution network management, whereby an acceptable level of risk is to be met through the appropriate application of controls during the life cycle of the gas distribution network. The performance-based approach allows innovation and development in the way gas distribution networks are to be managed, operated and maintained by specifying safety outcomes while allowing some flexibility on how these outcomes are to be delivered. Supporting this performance-based approach are methods known as means of conformance, which can be used by a practitioner to achieve an acceptable level of risk where the practitioner wants to minimise the effort required to undergo the more complex process offered through the performance-based approach of Part 1. These means of conformance are industry-recognised approaches to the control of threats. ASNZS4645 Part 2, Gas Distribution Network Steel Pipe Systems, is the first of two means of conformance parts. The second being Part 3, covering plastic pipe systems. The revisions to these have been based upon industry experience and research since the last releases of the standards in 2008. To this end, it's probably appropriate to reflect the work undertaken by Western Australia's technical regulator in raising the initial project to review the standard and for their continued support in bringing along with ATCO Gas some of their hard-won experiences to the table. The standard itself is based on 6 foundation elements. These are: a gas distribution network is designed and constructed to have sufficient controls to withstand the threats to which it may be subjected during its life cycle. Before a gas distribution network is placed into operation, it is inspected and tested to prove its integrity. Important matters relating to safety, engineering design, materials testing and inspection are reviewed, documented, recorded and approved in accordance with the SAOP. Operations and maintenance provide for continued monitoring and safe operation of the gas distribution network. Where changes occur in or to the gas distribution network which alter the design assumptions or affect the original integrity, appropriate steps are taken to assess the changes to ensure continued safe, reliable and affordable operation of the gas distribution network. When means of conformance alternatives to that provided in the standard are to be adopted, a review is to be undertaken to determine that the alternative is within the acceptable level of risk. So the revision itself also adhered to a bunch of principles that were developed that were agreed to by the committee at the first meeting to guide the development and settle any disputes or differing opinions. These are: the standard continues to define important principles to be followed through the life cycle of the gas distribution network. The standard continues to provide performance-based or risk-based requirements for the gas distribution network safety. The standard continues to provide prescriptive, deemed to comply, means of compliance in support of those performance requirements. These prescriptive elements need to be evidence-based. The standard continues to allow for alternate means of compliance provided acceptable risk outcomes can be demonstrated. The standard ensures that its scope limits should be clear in relation to the related standards such as pipeline standards and the consumer piping standards to avoid overlaps or gaps. The standard itself is self-contained to the highest level practicable to ensure any future inconsistency, including minimisation of external references, and that's a large impact upon Part 2's development, as you'll see later on. The standard promotes efficiency to target reduced costs and to ensure no undue imposition of any new requirements that leads to inefficient or imprudent costs. The standard is to be developed based on accepted engineering principles, including robust review and analysis of information to ensure sound technical outcomes that seek to eliminate opinion in the place of fact. The standard promotes harmonisation across the industry, including the areas of definition of acceptable risk, definition of the demonstration of a law, and general nomenclature. And finally, the standard embodies the lessons learned since 2008, especially in definition, process, and implementation of key elements such as the FSA, SAOP, etc. So, finally, on to Part 2 of the standard itself. Now, these slides and bullet points are generally in the same order as they appear in the draft to help you follow through any changes to the standards. Also, while reviewing the standard and the changes, it's also important to remember steel's role in networks where it is generally used for higher risk scenarios, either because of the carrying pressure, main size, or the location of the main itself. So while its level of usage may have diminished over time, its importance certainly hasn't. So, early in 2013, as the precursor to setting up the review of the standard, the ENA conducted a survey for changes proposed to the standard. Further requests were also made for further issues in 2015 as part of the review, and additional items were picked up such as welding, pre-welding condition assessment, post-welding inspection and acceptance criteria, i.e. the involvement of welding inspectors as mandated by the reference to AS2885, crossings, casing supports and electrical isolation, and generally throughout the standard development we also picked up issues with alignment to Part 1 as a complete means of conformance, and also alignment to Part 2 and Part 3 between content, structure and layout. So for that, it's important that reviewers take a look at Part 2 and also Part 3 to ensure that where it's referenced in Part 1 as a means of conformance, that the requirements expected to adequately address the Part 1 performance requirements are actually present in those standards and achieve the desired outcomes of the standard itself. So some general items for the standard and also the rest of the presentation. In all three parts of the standards, that you'll note that the terminology of compliance has been corrected to conformance, as this better aligns with what the standards are, i.e. they're not law or regulations to be complied with, rather they're a standard to conform to. There's also been a number of general clean-up and clarifications, such as the changes from things like insulation to electrical insulation, although most of these changes are obviously self-explanatory. And then for the rest of this presentation, you'll note that some slides I've highlighted in blue text key items. These are generally areas of larger change or more significant change that the committee would request to draw your attention to, and where you may wish to concentrate your public comment. And the plus marks also mark additions to the standard itself. So, the content itself of the standard, you'll note, hasn't changed in terms of structure. However, there has been some restructuring within the sections itself to better align this standard with Part 1 and the requirements of Part 1, and Part 3 structure itself. The grey notes areas where there hasn't been too much change. The black is minor change, and the blue and the bold blue is area of significant change. Obviously, the area that we're keen to focus on here is welding, that you'll see has pretty much been entirely overhauled since the 2008 revision. So, starting with Section 1, Scope and General. Just prior to that, you'll notice that the standard has a new forward section that lists out the 5 fundamental principles for the standard suite. These have been broken out from the old preface and essentially remain unchanged. So they remain as a gas distribution network is designed and constructed to have controls in place to withstand the threats it faces. Again, it must be tested to prove its integrity before operation. Important matters relating to safety, design, materials, testing, operation, and inspection need to be reviewed and documented by a responsible person or persons. Operations and maintenance needs to provide for continued monitoring and safe operation, and when change occurs, it needs to be assessed to ensure continued safe operation. Also, the standards continue to apply for new networks and modification or augmentation to existing ones. You'll also note within the scope the operating temperature range applicable to where the standard is deemed to meet means of compliance or conformance has been reduced from a range of negative 30 degrees to plus 60 degrees, down from an upper limit of 120. This has been changed to better align with other design standards and the general temperatures that gas distribution networks are run and designed to. The applicable MAOP of this deemed to comply section remains at 1050 kPa, with any sections run above that needing to conform with the Part 1 Appendix A requirements for systems operating above 1050 kPa in jurisdictions that allow that to happen without AS2885. You'll also note that the scope exclusions have been removed and moved to Part 1 of the standards, as they're deemed not really appropriate for a means of conformance, as it should only be referred to where it is considered deemed to conform. On to Section 2, Materials and Components. The reclaimed Materials and Components section has been relocated to Part 1, as it was relevant for general materials, not just those used on steel distribution systems. The Materials Table 2.1 and 2.2 have been updated to correct and add in a few API valve standards. Additionally, ASTM A333 has been added into Table 2 as an appropriate steel pipe material to cover low temperature situations such as the outlet of network pressure reduction stations. Previous wording in the coding clause permitted the use of uncoated pipe where it was shown to be unnecessary for the operational life or conditions. That's since been removed, although if you wish to still do that, you can achieve that under Part 1, provided that a proper risk assessment is conducted. The requirement that coated pipe be supplied with certification covering the coating has also been added, although no colour specification has been listed due to the variability of offshore supply at the moment. The design section has seen some minor changes, or moderate changes rather. It has been aligned with Part 1 requirements and Part 3 structure. This has seen the introduction of an offset distance clause that aligns the structure with that of Part 3 for plastics, where the offset distance requirements are more specific. For the steel distribution section, the requirements are solely related to accessibility for maintenance and repair. And additionally, a prompt to consider the required resistance to penetration for a steel main where encroachment is unavoidable has also been added. The most significant introduction to the section is a marking of mains and services clause table. This addresses an omission in the previous version of the standard where it was being referenced in Part 1 without actually providing any requirements, just a circular reference back to Part 1. These requirements have now been added in and are based on a diameter and pressure matrix for guidance on when signage is required. It should meet the current practices of network owners and regulator expectations, but again, public comment is welcome on this section. The expansion and flexibility analysis has also been moved up out of the support sections as it was required for, or as it is required for the entire above ground system, including piping, not just the supports itself. Also, you'll note that some sections from construction have been moved out into a design section where they're more appropriate. This is the depth of cover, separation from other utilities, electrical hazards, and the section on components and prefabricated assemblies. But the largest change remains marking of mains and services, so I draw your attention there for public comment. By far and large, the largest change to the Part 2 standard is the welding section. It's been entirely overhauled, and if you actually do a comparison to the previous standard, the only word that remains the same is the word general in the first heading. This was done for a number of issues that were identified, and I'll go through that, but firstly, I'll just run through the previous approach in the 2008 edition. That permitted arc welding practices to ASNZS4645 Part 2, very conservative approach. Oxy welding was permitted as per AS4041 and ASNZS3992. It also permitted welding procedures already approved to the previous AS1697 2005 edition. And in accordance to the reference to 2805.2, it came with a few substitutions where welder qualification lasted a period of 2 years rather than 1. Limitations on weld reinforcement didn't apply except where radiography was applied. Seal welding of threaded joints was permitted. Condition assessment prior to welding in-service pipe was as per AS2885.2 and WTI 20 guidance, but it had NDT replaced by visual examination by appropriately trained personnel, and some basic guidance was provided in that area. So there were some issues that were identified with this previous approach. Firstly, it didn't acknowledge the varied risk of distribution welding. As all gas distribution operators would acknowledge, the risk associated with gas distribution assets varies greatly depending on the operating pressure, diameter, location. Welding ranges on distribution networks from low pressure welding or welding onto low pressure mains such as skinner tees for service connections, all the way up to large diameter, higher pressure welding on new assets. The 2008 version did not provide the flexibility to work within that risk range seen within distribution networks, and it mainly specified a conservative approach to AS2885.2 for use. This was acknowledged as being too onerous for most distribution welding applications, and the AS2885.2 requirements have also additionally become a bit more onerous with the latest revision of that standard. So it was therefore decided that AS4645.2, in alignment with the earlier principles, should have a standalone welding section. So that leads to the proposed solution that was implemented, or proposed rather, for public comment. Essentially, the section was entirely replaced. It was based on mostly AS 1967, but the 1981 version, as the 2008 version was already deemed unsuitable, or was deemed unsuitable as it was already too heavily reliant on AS2885's welding part. Sections were copied over from 1697 and it compared and then mostly modernised by bringing over elements that had been introduced into AS2885.2 that were deemed appropriate, and redundant sections such as those to do with sour gas and some sections like that were also left behind. One of the other areas that may require some public commenting, if any businesses are too heavily impacted by it, is the removal of oxy welding as a process. It was removed mainly because it was recognised that it's not really utilised anymore. But if this is an issue for your businesses, please provide public comment to that fact. Also, there's been no allowance made for automated or semi-automated welding. However, AS2885.2 and AS4041 remain as a listed means of compliance. So if areas of welding like that need to be used, then those standards can be referred to. So the revised Section 4 now covers what you would normally expect to see in a welding standard, as listed in the slide. These requirements were mainly taken from AS1697, with some aspects requiring some modernisation. AS2885 was used as a benchmark guide here for the modernisation where required, and feedback from the committee indicated that the requirements being imposed or applied are not too much different from what most gas distribution companies are doing at present. But I strongly encourage everyone to review this section and provide any comments you may have. The revised Section 4 also covers the requirements for welding onto a live pipe and the attachment of electrical connections, such as those used for cathodic protection and monitoring cables. The requirement for the two dot points in blue, so weld inspection requirements and welding onto live pipeline or mains, are based on a risk assessment to allow for the flexibility for different asset types on the distribution network as discussed previously. But I'll discuss that a little bit further in more detail later on. So section by section, for the welding section, we start off with a newly introduced safety section. This has been largely taken from AS2885.2, or ASNZS, sorry. It covers welder safety, and the FSA has been replaced, or has replaced, the construction safety plan requirement that is in ASNZS, apologies again, Part 2. The Welding Consumables section covering electrodes, fluxes, filler rods and gas mixtures was also taken from AS2885.2 as it's the most up-to-date standard. Prohibitions of welding covering environmental conditions and the like has been merged over from AS1697, along with general provisions of welding, and also the preheating section, along with a modernised note from WTIA Technical Note 1. This leads to rectification, post-weld heat treatment. That's been taken from ASNZS 2885.2. Although it's normally applicable for greater than 32 mm thicknesses, so public comments welcome here as to whether that's really required within a gas distribution network standard, or whether it should be simply left out for people to refer to AS2885.2 if they need to apply that kind of thing. The qualification of welding procedures is another area of larger change. That's been taken from AS1697. But updated so that butt weld qualifications also applies to fillet welding, That's no different to ASNZS4645.2 and also AS4041. It has the changes other than those essential variables that are listed are permitted by the network owner. Procedure requirements and essential variables list itself is from AS1697. The qualification of testing of welded joints has also been taken from AS1697. The number of samples in this table was tweaked a little bit with the addition for fillet welding if you wish to qualify only a fillet weld rather than a butt weld that's also applicable to fillet welding. The test requirements and acceptance conditions have been taken from AS2885.2 and still apply, so it shouldn't be too much of a shock to anyone there. So some of the numbers that have increased in that area are around the tensile testing that now requires a test for the smaller diameters. The pipe ranges itself that are applicable here are within the underneath 60.3 millimeters diameter and smaller, between 60.3 and 323.9 millimeters inclusive, and then the really large stuff that I doubt many people are really using over 323.9 millimeters. So that relates back to the procedures itself and also the essential variables listing that gives a fair range for applicable procedures that can be used on distribution networks. The thickness requirement groups here are less than 4.5 millimeter thickness. The next range up is between 4.5 and 20 millimeter thickness, so that should cover the vast majority, if not all, of distribution welding. And then greater than 20 mil, which would be on extremely rare circumstances. So I'd strongly encourage everyone to review their welding practices and procedures. These areas aren't too much different from AS285.2, the old 1697, and basically what most distribution businesses should be having in practice at present anyway. So the flexibility is there to allow for all distribution welding, and the procedures should be flexible to allow a range of welding over a range of asset classes. The next section up is the rectification of welds. That was taken from AS1697 and allows repairs only when permitted by the asset owner as a change to the original 1697. The inspection and testing of production welds has also changed a little bit. It requires a generic risk assessment to be completed by the task, so that can be by the qualification or the procedure that applies to skin and tee or whatever general field procedure that's being developed. Risk assessment determines the extent of the inspection required, i.e. radiographic inspection, between 10 and 100%, but as a minimum, each weld must be visually inspected. The largest area of change here is the welding of live steel gas distribution pipes, and an area where we strongly request public comment and review. This has been developed to require a risk assessment to assess the risk of blow-through. Risk assessment drives the requirements for inspection, preheating, and lowering of pressure, etc. And as a minimum, a visual and ultrasonic test should be completed on the main before welding. And as a minimum, a visual and ultrasonic test should be completed on the main before welding. The risks that shall be assessed in this area is that the safety of the welding crew and the surrounding community due to a blow-through. The risk assessment needs to determine what required mitigation measures are required. Guidelines for the risk assessment and inspection options are covered within a new section 4.15 of the standard. For both welding inspection and welding onto a live pipe, it was decided not to specify the requirements, but base the requirements on the outcomes of these risk assessments, as each distribution asset around the country varies drastically in risk, risk profile, age, condition, as well as the experience level of welders. And it's been noted that the newer welders are generally of less experience and rely more heavily on the procedures themselves. A newer section that's been brought over and amended is the attachment of electrical connections. It's been updated and brought over from AS1697 and updated with some sections from ASNZS4645 Aluminosionic or thermite welding has been updated from AS2885.2. We've had the addition of pin brazing added in, and the fillet welding lugs and bosses and pads has also been brought over from AS1697. Under construction, the next part, section 5. This has been aligned with part 1 requirements of and part 3 structure. It's got the flip side of the removal here for sections that have been moved over section 3 design. Offset distances have been added. Positioning, or the oddly named positioning, has been retitled to burial, and cleaning internally has been moved after backfill to put it into a more logical order. One of the areas that we'd request comment on would be coating shall be tested prior to burial and should be tested after. This has changed from a should and should requirement in the previous standards. Also, there's a new trenchless installation section which defines some requirements for a written procedure. This replaces the very brief section on directional drilling that was in the previous section. Additionally, the electrical hazard section has been renamed and updated to reflect electrical hazards that are only applicable during the construction phase itself. Section 6, pressure testing. The safety section has been moved up and revised in line with Part 3 plastics to specifically call out the increased risk for compressible test fluids, so air testing or pneumatic testing rather than hydro testing. Introducing tested and certified inspected equipment requirements, calling out the risk of potential for projectiles, and the requirement for exclusion zones to be established at a minimum of the inlet and outlet ends or exposed ends of the test section itself. The testing program itself has seen some additions to add in equipment requirements, including sensitivity and accuracy, a depressurization process, safety precautions and emergency response, and the impact of elevation changes, that's only really applicable for hydro testing. Also, the leak testing preparation of test section has had a change to state specifically that valves shall not be used as a means of isolation. This again is an area where we request public comment to confirm that the requirement is not too onerous or not practical for distribution networks. And conversely, that the regulators agree with that approach. So Section 7, commissioning. The planning and purging section has seen a general clean-up to its wording to make previous requirements like pre-pressurizing of mains not immediately commissioned with air clearer. The section has seen the additional requirement of determining a method of measuring gas concentrations at 100%. And also locating purge points to prevent the trapping of air within mains themselves or services. Section 8, maintenance. Again, this section's seen a general clean-up of wording. It's been aligned with Part 3 and tweaked a little bit. And the electrical hazards has been added in to include testing installed mitigation methods to maintain a safe working environment, in addition to procedural control. So that leads us to the tail end of the standard itself, which is the 3 appendices. So Appendix A, the reference documents. This section, the sections in black are the additional standards, and the sections in grey are those that have been removed as references. So methods for Charpy testing have been added in line with the requirements of welding qualifications, or weld procedures, qualifications. Also added in has been a reference to high-strength steel fasteners and a few WTIA technical notes in line with the references that are in AS2885. Removals have mostly revolved around redundant standards, such as AS5601, which doesn't apply to gas distribution networks, and also some storage and handling of LPG gas, which doesn't apply for this standard. Appendix B, pressure test methods. There's really been no change to that section at all other than the title itself. So nothing too much to worry about there. That then leads us to Appendix C, which is another area of large change. This does remain informative. It's been based on amendments and work performed by the Western Australian regulator alongside ACTO Gas. The publication of their investigative report into this work is available on the GTRC website. The address is up there. And basically it was built to address the risk of static build-up and ignition, but predominantly for plastic mains. So this will be gone through more in the part 3 on Friday. Although what's good for the goose is good for the gander, so to speak, so it's been applied in part 2 as well there. Essentially what it aims to achieve is limiting the discharge velocity of purging to 20 metres a second. So that's a level at which research shows static build-up is limited. It does this via an orifice plate on the purge stack and limiting pressures across that orifice plate to a 7 kPa pressure drop. To assist network owners with that, there's been orifice plate sizing provided over a range of sizes and pressures. And additionally, separate clauses have been provided for stage and gradual approaches. And a new branch purge clause has been added as well, but they all rely on the same methodology of a orifice plate and 7 kPa pressure drop, essentially. It's just achieved via a different mechanism. So just running through the contents of the standard again and basically requesting areas of public comment. We'd like to request that public comment is focused obviously on the welding section, which has seen the largest change. The requirements shouldn't be too surprising, being based on the old AS1697, which then led to pretty much the old AS4645 and also AS2885 requirements. And also the newer direct purging methods requirements in Appendix C, although that commentary should be similar to Part 3's commentary as well. So to do that, again, all 3 sections are out for public comment at present. ENA, thankfully, has sponsored 3 webinars covering these sessions, with the 3rd on Friday covering plastics. Public comment closes on the 26th of April this month, and for public comment, it should be submitted via the Standards Australia website at standards.org.au, with a link available in the bottom right-hand corner to obtain copies of the draft standards and also the submission of comments itself. So finally, if there's any questions, again, I've got Mark Annette, a Standards Committee member sitting next to me, and also Mark Dragar, the chair of the Part 2 subcommittee, on the line. So I'm happy to take any questions, and if they can't be answered by myself or one of these 2 guys, then feel free to either submit them back through public comment and we'll endeavour to get something back to you. I'll leave it open to questions. So Susan's asked, for Section 4.15 Part 3, Risk Assessment, did the committee consider what, if any, documentation is required for the risk assessment? I'm sure the intention isn't the FSA approach, and it should refer to AS4645, which refers to AS31000 for user guidance. That would be the case. Essentially, any of these sections for risk assessments would be cut down FSA risk assessment in line with the requirements of ISO 31000. So that's just generally a likelihood sequence style matrix, and basically to align any requirements that are imposed or procedural aspects that are put in line with the risk assessment. So the mitigation measures should be in line with the deemed risk level. Anything else? Okay. If there's no further questions, I'd like to thank Dennis and the E&A for hosting the webinar, and I'll hand over to him to close out the webinar. Thank you.
Thanks, Anthony. That's a good overview you provided on the updates to AS4645. There's lots of changes in the welding section, so it's good to see. So I'd also like to thank Mark Drager and Mark Annett for being on standby for helping with questions. Just a couple of reminders. First one, as Anthony noted, make sure you provide your feedback through the Australian Standards website, please. And the second reminder is that this webinar and also the one on Monday and the one that we will have on Friday will be available through our YouTube website, and we'll send out the details for that after the Friday's webinar, so we'll email those details out to you. With that, I'll now close the webinar and wish you all a good day. Thank you.